Okay, this is Christopher Parham, otherwise known as Ice Cube 57 on the Atmosphere Forum, and I just wanted to do a video of the inverter setup that I have in the Chevy Volt here. This is a 2,000 watt pure sine wave inverter I got on discount for about $220 on Amazon. It was a used return. I have a DC clamp meter to show how many amps the inverter is pulling. I have a heater here that does about 1400-ish watts, and so like right now the inverter is off, and there's no draw or anything. It's not on. Switches on the front. Turn it on. So we're sitting at about 12.9, 12.8. The car is on up there. Everything is turned off in the car. Radio, all of that stuff, other than, like, you know, some of the lights here. I actually measured the draw on this inverter, and it was actually coming out at around 0.75, so this is out by a little bit, but it's rather close. But it's 0.75 amps at idle, so it's doing about 0.85, 0.9. So again, like I said, it's a little bit out. But I'm gonna just go ahead and cut this guy on just to show what it does. And it's drawing its power from, there's a 12-volt battery right about here, and then up in there in the floor there's a APM, or otherwise known as an auxiliary power control module. This is a module that takes the 420 to 300-ish volt main battery that runs down the center of a car. It takes that and converts it to, you know, 12 to 15 volts. I've seen about 15.1, 15.2 on this thing. So, and that's when it's the battery is fully topped off. So, you know, it takes the main voltage, drops it down to 12 volts, keeps the main battery charged, the main 12-volt battery charged. And so the way this is set up, the battery is acting as a buffer, but the APM is like constantly topping off the battery and supplying power to the inverter. Now I have the inverter hooked up with two 0-gauge leads, and they're actually closer to 2-gauge. The system only needed one set of 2-gauge leads, but anything worth doing is worth overdoing. So that's why I installed, you know, double the leads, and they actually run in here and they run behind this plate here. One goes to a ground terminal and the other one goes on the battery. Let's see, other than that, there really isn't there much to explain. Also, the positive line, each line is fused at 150 amps. So this inverter supposedly has a surge up to 300 amps, or is capable of a surge up to 300 amps. So I figured 150 per line, and if they're supposedly sharing the load like they're supposed to, then it's fused appropriately. But I'm going to go ahead, you know, and it's already turned on down here, so I'm going to turn on the load up here. So we have this heater is blowing, and we're just looking at amperage. The heater has a slow ramp, so we're doing about 33 amps. And then looking at the wattage down here, it's slowly ramping up, and you'll see like the voltage after we get in this test a little bit. You'll see the voltage sag down, then it kind of jumps back up. It'll sag down a little bit and jumps back up, and I believe that's the APM monitoring the voltage and kind of supplying more amps. But it seems like we're still, I was going to say we're still kind of climbing, but we're at 680 watts, which is 690 watts, which is half the capacity of this heater, and we're doing 56 amps. So if I turn this to the peak, well, not the peak, but the peak of the heater here, we're going to go ahead and switch that up even higher. see the amperage of that climb up to 100, 110. So we got 1370 watts, and it's 120 amps on the DC side, and it's holding steady there. And I had this running for like 20-30 minutes yesterday, and every surface that I could touch here was cool. Not lukewarm or anything, it was like cool to the touch. So this isn't one of those cheap ass inverters that gets hot after 5 or 10 minutes. And then I had this running for about 20-30 minutes, no issue. And I doubt I'll ever run it this hard. But yeah, it's a pretty good setup here. Okay, this is just another follow-up video just to kind of show the surge capacity. It's doing about a 1400 watt load with this heater. I have a drill here, and it's not like loaded or anything. I'm gonna just, rev it up a few times. So, see if I can get the right angle. So we have no problem handling surges on this thing. I mean, this is really a really stout inverter, and again, it's like room temperature. I mean, it's not hot at all. Let me go get my my laser temp probe so I can show you that there's no heat building up on this. This is hot. This is running and everything, but there's been no heat build up. It's not struggling with it. This is like the best $220 I've ever spent for a 2000 watt inverter, because mainly this could power almost my entire house for the most part. So I'm gonna go get my temp probe and show it all on the black, because black is supposed to be a good conductive indicator with these laser infrared thermometers. So and I'll just prove that it's just really there's no heat buildup. We're still running. I got my probe here, just gonna shine it. So there's a little bit of heat. So I'm trying to get the right angle with this. There we go. So it looks like 86 degrees. So I'm shining back there where the exhaust is. The plastic around back there. The plastic back there is hotter than what this unit is reaching. The heat, I mean, it feels like a blow dryer on a cool setting. I mean, it's not hot at all. Doesn't feel like there's any significant heat. Well, 2 is twice as better, so I end up getting 2 heaters. I'm probably going to run one on high and the other one on low. So let's see what we do here. Another part of this video is to follow up with a question about the DC to DC converter in here and was it getting hot. I mean, even on standby it's quite warm, and then like I said, the DC to DC converter is under here. There's a tray up under here, and then there's the DC to DC up here, and the battery's back here. And even with the cover off and the car was at idle, it was quite warm. But one thing I noticed, there's a duct that comes in from over here. Somehow it's sucking in air through a little tube over here. I think it's pulling it from the cabin from somehow. It's going through here, it goes to the DC to DC, and it kind of goes under it somehow. And then there's another duct that comes out and goes down over here to a blower. So this blower, it seems like it should be sucking the air through. If it's not sucking, it's blowing. And this blower is really like the size. It's really beefy. I mean, so I'm assuming that if it does get to a temperature to where it calls up for that blower to kick on, that blower is so beefy down there, like I don't think it's going to have any problem cooling that DC to DC off. It's not passively cool, it's definitely actively cooled. I'm going to go ahead and edit up this video and conclude this, so thanks for watching.